as in I just started recording. You got what you need. Alright, so the first thing I'm going to do is a quick review of yesterday. Yesterday said we had the OSI model. This is a set of guidelines for two sets of information. The lower layers of the OSI model are the physical data link network and transport layer. These lower layers are what needs to be done to data before it can be transported. So basically a piece of data will go through these layers and have information added to it so that it can be successfully delivered between two networks or between two nodes within the same network. Then the upper layers, the application, presentation, and session layer, are what needs to be done to data before it can be presented by an application. This would be things like in a TCP connection, we need to make a end-to-end connection so we can deliver all the packets and they can be reassembled. The presentation layer is anything that needs to be done to data, like formatting, decompression, encryption, syntax reconstruction, stuff like that. Different languages, formatting on the web page, and whether or not it's encryption. Obviously, if we're using our credit card information, it needs to be encrypted so that people can't get our information along the way. And then the application layer is simply responsible for processing requests for services and then providing those services. So the term that we use for computers requesting a service is a client, and then the term that we use for machines that provide services are servers. And we're going to go over the two different types of networks also during this section. A couple of words to help us understand along the way was protocol, that means rules. Logical, which means software. ISP, this is who you pay your internet bill to, or the internet service provider. They're providing your service to the internet. What is a network? It's a group of connected devices. And the goal of networking is to make remote resources seem like they're local. So off the OSI model, which is a guideline of how communications work, what steps need to be met in order to have successful communication end-to-end. ARPA, now DARPA, and 4 universities came up with what we call the TCP/IP protocol suite, which is just a collection of answers to these questions of how do I make sure that we get end-to-end reliable transfer. And so that model is ATIN, or Application Transport, Internetwork, and Network Access. These line up specifically network, data link, transport, application session. So they're exactly the same. It's just this is the physical model that was created off the set of guidelines that needed to be answered. And of course, you're responsible for making sure you memorize those two out of each other. All right, so before we get started on the OSI model by layer, what I'm going to do is explain the two different types of networks quickly. And we're also going to be exposed to our first network diagram. So if you looked in the book, and really, if you're taking the Power Learning class, you know that one of the things that you should do is, just because you've been assigned chapter 1 doesn't mean that you should rush straight to the page that you've been told to read. What you should do is explore the book a little bit. On the first day when you got those textbooks, you should have cracked them open and looked at the outline. What is the preface all about? And in the preface, it will tell you that the things that you're going to learn in this book should help you successfully be able to pass the CCNA test. The next thing you get is an outline, and each chapter tells you what each chapter is about. And leading up to that, what you got was a diagram of topologies. What is a bus topology? Basically a coaxial cable with conjoined computers on it with terminators on the end so that information doesn't just travel up and down the cable. You should have learned this in your Managing Networks class. Then we have the star topology, most often seen in local area networks. That is a device in the middle and every other device connects to it to be able to get network traffic delivered. Then we had the mesh, which is every device on the network is connected to every other device on the network. Now the partial mesh is most every device connected to every other device on the network. And of course these are logical topologies, which means they're not necessarily wired the way that they were described, but traffic flows in the way that we just described. The most commonly used topology on a LAN is the star, and the most commonly used topology in the wide area network, or the WAN, this partial mesh. The others are they're outdated. We use the full mesh was like a token ring where everybody's connected to each other, or just a regular ring. The token being who's giving permission for you to transmit at any given time. So all of that you should have learned in your Managing Networks class, and that's just a quick reminder of those topologies. In this class, we're going to focus on physical topologies, and the physical topology is how are these actually connected. So we're not going to so much draw like as if it was laid out in the classroom, but a network cable will represent the connection between two devices. Alright, so the first network we're going to talk about is the kind that you probably see at home. The most notable thing about at home is you probably don't have a server at home. What you usually have is an interface to the internet. So the first thing I'm going to draw is our internet. And of course we always use the symbol for the cloud. The cloud for the internet has a couple of meanings. One of them, of course, is simple. Internet. I drew this in a light green. It might be hard to see on the camera. But you know, the big I there, we all know that means internet. But what we suspect is that they also want to know, like, do you know the protocols that function out in the internet? And of course, you should have learned in another class. If not, just try to, you know, make some notations to go back over some ideas. What technology works in the WAN? Because we don't talk a lot about the WAN because you're here to become a network technician, and that happens in local area networks. But in order to understand how data travels, then you should know a little bit about these two services, and that is ATM and frame relay. Now, as we learn what a frame is, that will make more sense, because then frame relay makes sense. Oh, it must be, you know, what a relay race is. You hand off the stick from one person to the next. And when you know what a frame is, then you'll know that it's just relaying frames and how that will function. So that's going to be described at the data link layer, and it'll make more sense for us. ATM is just another protocol that functions on the wide area network. And this one is just a step higher than frame relay. Of course, frame will be looking at one layer's addressing, and then your ATM looks at a higher layer of addressing. And we'll understand addressing once we break down this OSI model by layer. Okay, so our connection to the internet, you'll notice in this class, we don't mention the fact that between the internet and your first device is going to be your internet service provider. But that should be a given, so I'm going to draw it here. I'm going to draw this little line, and we'll say, you know, here's the internet service provider, because you got to go there before you can get your connection to the internet. They are most likely providing you a connection to the web. So communication in the wide area network is mostly between ISPs, and then is routed to you afterwards. Now, in order for you to communicate on today's networks, basically, if you're using a phone line, what you've got really going on is a conversion of digital data into audio, and this audio is put out on a phone line, and then it travels as audio down the phone line. It hits another device that translates analog to digital signals, and that's what we call those audio signals. As a matter of fact, if you looked at an analog signal, they look like this, and that kind of looks like a sound wave, doesn't it? And digital signals look like this. They're squared off. They are there or not there, meaning, you know, a 1, a 0, on, off. Electricity is present or electricity is not present. And the definition of analog means continuous, and the definition of digital is granulated. Granulated just means it's been divided up into small segments. Normally I'd point out a couple of clocks and watches, and we would laugh that most people think that when you have numbers showing up on your clock, that that's digital, and when we point to the regular hands, they go, oh, well, that must be analog. But the clock on the wall is also divided by minutes and has a second hand that clicks. That's granulated. So that's a digital clock. Your digital numbered clock is a digital clock. The only true analog clock are things like water clocks and a sundial. It's just a continuous cycle that occurs. It never ends. The reason that that's important is that the type of analog signals that we use out on the WAN have to be converted from voice. So old dial-up, when we connected, you could hear the beep and the these were actually audio waves that had to be converted back into digital signals. So there's a device. This device is called a modem. Sometimes it's a terminal adapter, but every time at home, and that's what we're talking about here, it's a modem. What does modem stand for? Any idea out there in the peanut gallery?
Modem.
Yeah, what does modem stand for? You remember? Ooh, you better bone up because that's definitely going to be on the certification test. The mo for modem is modulate, and the dem is demodulate. That's a fancy word to mean converting between analog and digital. So the modem is here. This is what gives us our connection distance between the digital side of our network and the analog side of our network. So the modem is not always a modem, but we're going to say modem because we're going to assume that you probably have DSL or cable. Because at home, 95% of the time that's the case. Sometimes you might have satellite, and rarely you might find a case where somebody has a T1 or ISDN connection to a phone line. But that's usually because they live out in the boonies, or maybe they live in a house apartment above their business, you know, in the city or something like that. And they weren't zoned to get residential connection. Alright, so I'm going to switch to the local area network, and here's our color. So you'll notice this device is the last device before you get out to the wide area network. Of course, everything outside of you is going to be the wide area network, so we'll just put that right there. Now you'll hear the next device, which is a router, and you'll notice that when I was talking about the symbols in the book, the symbol for a router is a circle. And the router, basically, they say is the gateway, so I like to draw a dotted line, and we'll learn more about why is there a dotted line here. But next to it, I'll say its nickname is the gateway. When is a router's nickname gateway? Or why is a router's name gateway? Either one of those. What do you think?
Because it has a secure barrier.
Barrier between what and what?
Barrier between connection coming in, connection going out.
That's true, and the word you want to look for when you say that is that it's the barrier between the local area network and the wide area network. That's basically the way it's going to be said on a certification test. So the gateway, truthfully, the definition is the router that you need to pass through on the way out of your network. In this network diagram, we're only going to have one router, but you'll learn as we move into a couple more chapters, you can use a couple of extra routers inside your network to create subnetworks or some separation, so some traffic out of one part of your network can't be seen by another part of your network. This is important when you have things like payroll and human resources within your particular network, because you don't want employees with open access to a network to be able to go into human resources and look at other people's personnel files. First of all, it's illegal. But the second thing you don't want is people being able to get in and look at pay rates or get into payroll and change the times on their time cards, which is basically all going electronic now. You're clocking in on a pad and it keeps tracking the computer. So changing time cards now is less of a physical thing. You can get in there and change it. Nobody really knows. Because there's no real handwritten, initialing or signing. I made a change and then you sign it. Usually, like, I made a change, and if you knew the passcode to get in, they assume that that's the person that made the change, and there's no real proof without biometrics on the access point of whatever you're making the change. But so we have a router. It's our gateway between the local area network and the WAN, or more specifically, it's the exit from your network to other networks. So inside my network, I could have a couple of subnets, but all of those subnets still would have a gateway, and that gateway would be the last router before what we call this device here. It has a generic term, and we'll get into those generic terms later. We want to learn the specific terms right now. In this particular case, the router will then pass information to the modem. The modem's only job is to modulate, demodulate, or translate and convert between analog and digital signals. So, who purchases the router most of the time? You. But where did you get this modem? Do you go to the store and buy a modem most of the time? No. You can. But most of the time when you go to Time Warner or AT&T or Bell South or Verizon, what you'll find is that when you pay up your bill and say I want to get some service and sign up for service, they provide you a modem. They either hand it to you or they mail it to you, you plug it in, and then sometimes it'll have routing functions built in. They'll ask you, did you want a modem with or without networking? So that basically is just some software called firmware. That means it's burned into a chip, firmware, that allows you to either have networking or not. And that just means that there's a protocol that's been installed called the point-to-point protocol. And we'll learn more about that in a couple of weeks when we talk about WAN-side technologies. So the modem is provided usually by the ISP. So it's going to get a special name later. Alright, so the router you've purchased and you've got that installed. Most routers nowadays, when you buy them for the home, come with a switch built in, and maybe they're wireless, but we're not going to consider those to be the same device. So even if it was all in one box, I'm still going to draw a piece of cable, because we will just say that inside the router itself, that the cable is maybe this long. It still exists, but it's super tiny within a box. Then we would probably have the device here, so the service is a switch. In, of course, corporate world, that'll be a separate box. And here's an example of that. For home, we have a single box, and here we have a wireless access point. I can tell because it has an antenna. On the back here, we have a RJ11 connection for a phone line, so we know that that's probably a modem. Then we have 4 Ethernet jacks, or 4 RJ45 connection jacks here. And this is the switch that allows 4 computers to connect. And the routing function is inside the box. What is a router? And that'll be defined when we get to layer 3, when we talk about what functions make it a router. So people like, oh, I need a router, but somebody could say, I need a modem, but they could also say, I need a switch, or I need a wireless access point. This is all of them. So it would be hard for me to draw this all in one box. I'd have to draw a bunch of squares with some names. So it's easier if we just draw the service. And that's because out in the real world, a router can be a box like this, a small box like this. And a router can be a large one, just like this, corporate side. And you'll notice on the back there's not a whole bunch of connections for a bunch of computers. If you look at what they're labeled, you say, well, I see a bunch of holes. But if you read them, this one says 56K CSU DSU. You're going to learn what that means later, but the 56K part lets you know that it's slow. So it's probably some older dial-up modem or something like that that it's going to connect to. Here we have a T1 CSU DSU. So T1, if you look that up from your managing networks, you'll know that that's only 1.5 megabits per second. That's about 187K download if you're lucky. Then we have Ethernet. This is going to go on the switching side. So that's actually the part that would plug into the switch so that we can plug in multiple computers. We have console and auxiliary. You'll learn about these in a couple of weeks. This is how we go into the router to make changes, set an IP address, or create an access list that allows us to stop certain traffic. So there's no switching functions in this box. So in the corporate world, we have a switch. So home, corporate, same way. I'm just going to draw it as a service with a cable because it's kind of inside the box. And lastly, we'll probably have a computer. So I'll just draw a little C right there. So this, if you have high-speed internet at home, you have ISP internet, you do. And you have more than one computer at home? Just the one computer. So this is probably exactly what your diagram would look like at home. Obviously it's not drawing it around the house. But your computer is connected to the switching function, which may or may not be inside of a router box. We're showing the routing function. And then we have the modem, which is translating from digital to analog. Your traffic then goes to your internet service provider, which then connects you to the main toll network. So, this type of network has some specific traits about it. How can I know that I have this type of network? One, most likely, I'm going to switch to red. We have some services that are running from the router, and one of those services is DHCP. So in this type of network, DHCP will most likely be running on the router. Another service that runs on the router in this type of network is DNS. And these are two very important services that we're going to talk about in the coming weeks. And we're going to dissect them and diagram them. So these services are probably running on the router. Another thing we might notice about this network is there is no dedicated server. And because there's no dedicated server, then we need to note that every node, do you remember what node means from another class?
It's the little piece on the wire.
Node is any device on a network that can get an IP address. I know it's a different way to use node than we're used to. Usually a lymph node or something like that is something small at the end of a, whether it be a, I don't want to get too medical on you, you're an MT student anyway, but they're usually it's some kind of sac thing on the end of a tube thing. Would be a node, kind of an idea. But this node, if you think about it, it's the same thing. At the end of a cable, there's a device that's plugged onto it and it got an IP address. So visually, it actually is kind of the same thing. So a node is a device on the network that got an IP address. Every node on the network can be a client or a server. Now, what does that mean? And I think to help understand what that means, all I should probably do is define client and server, because then you'll understand what that sentence means specifically. So, a client requests services, and a server provides services. This style of network is called a peer-to-peer network. So if you had to write a definition of what is a peer-to-peer network, what do you think the answer would be?
Connections from local networks.
You can information right on the board to help define itself. So to define a peer-to-peer network, it's every node on a network can be a client or a server. What is a client and a server? A client requests services and a service provides services. So, and also peer-to-peer network, the client requests services and a server provides services. So it goes in a nice little circle to help you understand. And your little nice diagram in the middle. Alright, so this is the basic idea, and we're going to expand on this idea over the next couple of weeks. Alright, so I'll give you a minute if you want anything to write down. Just let me know when you're done so I can erase it. You good? Alright.
Listen.
Yeah, keep. That's grown. He's been in here a while. Or he came in here recently. Normally they're kind of clear. They look like a tiger lizard. And we're going to take a little lizard break. Going crazy with the camera now. Alright, wait till much. Alright, so the next kind of network is, the one before this was what you would expect to see at home, a peer-to-peer style. This is the type that you'll expect to see in the office kind of environment. It's known as the enterprise, also known as the client-server model. Network. Alright, so again, we have our internet, and again I'm going to draw in the ISP. After today I won't be drawing in the ISP. There's not too much for us to discuss because we're going to be going over LAN side technologies. Only at the very end will we mention some WAN side technologies, and then we'll get more into those in the server class, since you usually have to leave your network and enter some other person's network in order to interface with their server. To get any web page, that's the process. So, then of course the modem. So that's our digital to analog conversion box. Now in the case of the enterprise network, remember earlier I said it doesn't necessarily have to be a modem, so I'm going to put in parentheses that it might also be another device called a terminal adapter. It basically does the same job of a modem. It's just that it connects to a different type of network. Alright, so switch it back to black for the LAN side. Showing the cable, and of course we have a router. The symbol for a router again is a circle. And I forgot to mention that the symbol for a switch is a square. And of course these are Cisco proprietary symbols. And in this case we might even have a couple of switches, because enterprise networks are usually pretty large. microphone for agreeing with me. So here I have 4 switches connected, and we're just going to say that it's because we have some long cable distances, offices or classrooms that are far apart. And I'm a little lazy in drawing computers, so I have a lot of computers to draw. I just use the letter C. My normal computer is, you know, the little screen with a tower. Some static on my screen. So I'll just do that when I only have a couple to draw. You can see here I would have had 5 to draw. I've been all day drawing computers. And in some of the larger networks it can be a little tiring and time wasting. But in here, what we'll have is probably a server, and I'm also going to add a network printer. These are 2 common sites on an enterprise network. The server is going to allow us to be able to have some security on our network. The kinds of things that a server are responsible for when you have a server on your network are, well, the first thing is we go ahead and turn over DHCP to a server. And what I'm going to do is draw in a list here, and then I'll just kind of like, a little notation there. DHCP, the Dynamic Host Configuration Protocol. Of course, you should know a little bit about that, and if you don't, we are going to cover it here in a couple of weeks. Don't be afraid to crack open the book and take a look at that. DNS is another one that you should know. I'm going to say it again, I said it before. These are 2 of the most important services for a network administrator, because DHCP is how computers are able to get their IP addresses automatically. A service assigns them an IP address, and that's what gives them the ability to pass through network devices, routers, to get to other networks or the internet. DNS, every time you type in a web page, DNS is a service that translates text that you wrote to the IP address that the computer understands. So it's text to IP address translation for web pages. And the last service that we're going to make a big deal about is authentication. And what authentication means in regular words is username and password. The authentication for username and password is so that you can prove that you're allowed to access one of these computers and have it access the network. If you're not supposed to be there, you won't have a username and password, and the computer will be locked out of the network and you won't be able to connect. This enterprise network in the client-server model, clients request services, servers provide services, has a server that takes over management duties for the network. It runs DHCP, managing IP addresses, DNS, managing web page connections and authentication, managing security access to the network. And I'll see you after the break.